Thanks, Michael. I appreciate the opportunity, and I'm honored to be able to present this data on this distinguished panel on pavement markings. Under the Measure Across America project initiatives, our job, with the help of our partners, was to objectively assess thousands of miles of pavement markings. Our primary purpose is to promote the advancement of pavement marking management for both human and machine driving. We truly believe when it comes to roadway safety that lives are on the line. So with the Measure Across America, we had three initiatives. The first initiative was the pilot project, and this was in 2018. And our primary objectives was to, one, develop acquisition process. Two was to determine the assessment criteria, what type of data we needed to acquire or we could acquire, and what was useful as well. Also, the road type comparison between a interstate and non-interstate roadway systems. Next was the coast to coast in 2019. Many of you have already seen a presentation on that. In that particular presentation or that particular assessment, we were looking to acquire multi-state data. We also wanted to have a comparison of regional and environmental factors, and also highlight the special discoveries that we knew we would find as we moved across this many states and this much of a marking system. Lastly is the snow belt, and that started in 2020, this past fall, and its objectives is to acquire toll road data. Remember, we had interstate and off interstate roadways, but we had not collected data on toll roads yet. So that was an added objective. Also to compare pre and post plow data. This was the primary purpose for this particular initiative, was to compare. So we'll go in there, we went in there in the fall, and we'll go back in the spring and measure and assess the same markings of the same roadways, and we'll see what type of impact the plow systems and the plow processes had on the pavement markings. And then lastly was also to run tandem retroreflectometers. That's right, tandem. We have one on each side of the vehicle, and to operate them simultaneously and collect information on two lines in the time that we normally would collect only one marking. So going to equipment, we use the mobile retroreflectometer, the Road Vista Laser Lux G7, or known as the LLG7 color unit, and it's squid mount, and that's so I didn't have to drill holes in the side of my vehicle. Also, for operation control, we use the Microsoft Surface Pro and the Samsung S9. It's great to be able to operate one piece of equipment with two control devices at the same time. Also management, data management, we simply used Excel and Google Maps. I say simply used, there was a lot of data, so I don't know how simple it was in the end, but I'll share that in a moment. We used, as our vehicle, we used the Model X, Tesla Model X with hardware 2 and enhanced autopilot. So to provide you with some combined data, we'll start with, we assessed in all three assessments combined, we've assessed so far over 9,100 miles at 69 miles an hour. Now, this was pretty cool. That's a lot of speed if you think about, for a system-wide assessment in all these different environments. It was helped quite a bit by driving through the southwestern states with 80-mile-an-hour posted speed limits, that's for sure. Next is we went across 24 states in total and a total of 20 days of assessment. We did 120 million valid scans. That's about 13,000 valid scans per mile. That's scans that says there is a marking here. It resulted in 91,000 records. So you can imagine the size of that Excel spreadsheet I was talking about. We went across 4 different road types. Again, interstate, non-interstate over 50, non-interstate under 50, and toll roads. Those were the 4 classifications of road types that we used. And then we went across, of course, 98 different roads. We counted 218,000 RPMs. We measured an average retroreflectivity of the markings at 191 millicandela per meter squared per lux. Now, understand, to me, the most important thing is the buckets that it falls in. Different roads fell in different buckets, but in this particular case, you see 65% of the markings that we assessed fell under 200 millicandela and 20% under 100. Interesting that we had about 5% that was over 500. Those were pretty good. We saw that in Pennsylvania, California, some, I think, in New Mexico and Georgia. We saw some pretty good markings there above that 500 range. Next would be the line width. We had an average reflective line width, nighttime visibility width of the line at 4.6 inches. And unfortunately, we found about 20% of the markings failed and fell outside of the ASTM color box for nighttime color. This was, of course, mostly in yellow. So we had many discoveries. We have videos on our YouTube channel that go into far more detail about these discoveries, but I'll briefly just kind of highlight a few that we found. One was the importance of marking width and contrast, specifically to that of automated vehicles. Next was the impact of pavement texture and retroreflectivity. This, you can see that there is a difference in the coverage of the marking material from the direction of travel of the equipment and the opposite direction of travel. We did find retroreflectivity variances between the two different directions on that particular marking. Again, great video on that information. Next is the impact of pavement color. Basically, we just discovered that the importance of the lighter the pavement, the more contrast and retroreflectivity that you're going to need on that pavement marking. Next is the discovery number 9, which was about merges and their impact on CAVs. In our autopilot system, we found that the majority of the major interruptions where we actually had to take control were due to lane drops or lane adds. This is a great example of a lane drop, a merge in a work zone. There is no marking along those barrels. So what happens is the vehicle, remember, is operating as rails to a train. Markings are to an automated vehicle. And so therefore, there was a good chance that the vehicle could barrel into these barrels because there was no marking that told that car it needed to move to the left. Next is color. We talked a little bit about that being a very important issue, especially when you have a yellow marking that's fading toward the white box. This can be critical and cause wrong way driving on 2-lane roads that's divided by a yellow skip line. We also found that, speaking of color, that retroreflectivity does greatly impact the color reflection of the marking. The lower the retro, the more failure we found in color. The next discovery was this issue with sun glare and reflection. This occurs when the sun is about 30 degrees or less in front of the vehicle on an east-west road. It actually washes out the marking regardless of its color. What we found is that it was more important, the texture contrast was more important than the color contrast. So very interesting discovery there. And again, more video on that goes into details. Our lessons that we learned throughout these assessments is, one, is make sure that your setup is comprehensive and concise. Remember, these guys are driving at 60, 70 miles an hour down the road, and they don't have a lot of time to be figuring things out. So make sure your setup is good, that you know what data you're going to get and how you're going to get it. Next is speeds. Understand that no matter what type of equipment you're operating, the faster you're driving, the less scans you're going to get. Now with the LLG7, we were lucky because it scans at about 400 scans per second. So we really couldn't outrun. I think that's about 2 inches at 60 miles an hour. You're getting a scan every 2 inches. So, but not all instruments are the same. So make sure that you fall within the speed limitations of that equipment. Next is geometry, geometry, geometry. This is 30-meter geometry we're measuring in. So the distance of which you're scanning, the height of the equipment, the offset from the vehicle to the marking, and the leveling of that equipment is all critical, that it needs to be maintained. To remember that that can be affected by all kinds of things during assessment. It could be fuel burn, it could be tire pressure, It could be even swapping the driver and the operator if one is much if there's a large weight difference between the two. Literally can change the geometry of the instrument. The LG7 has an auto positioning system which takes care of most of this, but you need to be aware of, again, like for instance, how much distance that you have to be from the vehicle in front of you when you're operating the equipment, as an example. So geometry is super important. Also, the vehicle alignment, talking a little bit about geometry, making sure that the vehicle is aligned with the marking properly and according to its offset, and making sure we had like a 1 meter scan capability, so we could be off by about 1 meter. And the other thing with us is we were driving a Tesla and it maintained its alignment in the lane very well. We could set it and kind of forget it. Also, lighting, just make sure that you've got safety lighting on the vehicle. In fact, and not too much. In Kansas, we were pulled over at 1 o'clock in the morning because we had too much lighting and had to kick some of it back. They weren't too happy with us there. Personnel, training and responsibilities, make sure everybody knows what to do, when to do it, and how to do it. Super important. Environment, lighting and scanning, just remember that that again, really equipment restrictions. Just make sure that your equipment can handle day, night, and sun glare, or if not, that you work around those times. In most instruments, the LG7, because of its laser system, didn't have a problem with the glare, but most instruments will. You'll need to pull over to the side of the road, wait for that glare to go down, and then measure. Some instruments can measure at night, but not day, so just know the restrictions of your equipment. Moisture, know that dew, rain, fog, irrigation all dramatically affect the retroreflectivity of your markings. Temperature, high and low, just know that what your equipment temperature range, operation range is. We had no problem, even in the sun-filled hot desert in the summertime in the southwestern states, with operation. Where we had problem was when we were sitting for an hour charging the Tesla and the machine was sitting in the sunlight. At that time, we actually ended up putting an umbrella over it to keep it cool while we sat there. Markings, your guys need to know, understand the basics and troubleshooting of retroreflectivity, what the performance expectations and issues are of the equipment and the material, so that they know when there might be an instrument issue or so forth by looking at the markings. And material types, understand the elements in the binder and you know, the different types and what they do and what can cause problems. Basically plan for the unplanned. Weather, traffic, mechanical issues. We had weather and traffic issues, didn't have any mechanical issues, thank goodness, in any of our assessments thus far, but always be prepared. Weather can definitely put a damper on your assessment, and traffic definitely. Sometimes you need to measure at night, sometimes you need to measure in the daylight, depending on what type of traffic you're in. For the last part is just, why is pavement marking assessments important? Because you get comprehensive data, you get improved overall performance of your pavement marking system, and you improve your maintenance performance. You mark the roads that need to be remarked, and you leave alone those that don't, which ultimately saves the agency money. And of course, most importantly, is you improve the safety. Also, just a little warning here as I give this back to Michael and pass it on. Understand that this is data snapshots of the markings at a specific moment in time, but they are lagging indicators of the marking and its performance. So to get the most out of this data, you're going to need to take, it's critical to combine this data with historic and performance data, as well as material installation and environmental data. That's going to, you bring all that together, and that's going to help you have a comprehensive system in deciding on what type of markings you want to put down and when you want to replace those markings and so forth. So with that, I'm going to hand this back over to Michael, and we've got some guys following up that's going to tell us really how to bring all this data together. Thank you, Michael. I'll pass it back to you. I appreciate the opportunity.